Do it. So 7.8 factor polynomials completely. I am going to start off with an example. We're going to factor. And we're going to look at something that looks a little ornery. I'm sorry, ornery. 4x times x minus 3 plus 5 times x minus 3. And the problem says factor. Well, what hits me about this problem is I'm looking at it and I'm saying, that's not a factoring problem. It kind of looks like it's already like factored, right?
Multiply it or distribute and then factor it out.
We could. Okay, so now the reason why this isn't factored is for something to be factored, it can only be factors. It can only be multiplication. Do you see how we got this plus sign in the middle? Mm-hmm. That makes this not a factored problem. It's not done, okay? But what some of you might realize, well, and Titus said, well, you could just go ahead and multiply. And we've done this before, haven't we? Where we had to like multiply it out and then bring everything over, get it equal to 0, and then factor it. You could multiply this out and then start factoring. But Jasmine, what's something else you can do?
Just like take x minus 3 and then x plus 5. Like that's the other.
Oh, 4x?
Yeah.
Yes. Yes. What Jasmine's noticing is this thing has an x minus 3, doesn't it? As does this thing. So this is actually that last part of the AC method.
It's the last step.
But it's just, yeah, it's the last step, isn't it? When we learned the AC method, our last step was we would factor out the common binomial. So just kind of be on your toes here and realize, oh, wait a second. If this has an x minus 3 and that has an x minus 3, we can factor out the x minus 3. And what does it leave behind? 4x plus 5. And that looks factored. They're multiplying together. So, kind of interesting, huh? Now, if you did what Titus said and multiplied it all out and combined like terms and all that stuff, and then started factoring, you're going to get the same answer. It's just going to take longer. Yep. Are you guys good? Mm-hmm. Okay. Let's try another one. Let's try this. X to the third plus 2x squared plus 8x plus 16. Okay. Now this is not something we have done before. This is not review on this one, okay? And this really wasn't review either, technically. You got an idea, Silas?
Couldn't we like split it into two groups and then factor out like, because 8x and 16 or something you can factor out in x and x cubed and x 2x squared or something you can factor out. Couldn't you factor them as like separately?
Okay. Again, is that kind of like a step in our AC method?
Oh.
I think so, yeah. Now let's back things up. I like that, Silas. So yeah, but let's back things up a little bit. Could we maybe combine some like terms here?
No.
You can't, can you? You cannot. But that's an important thing to realize because guess what a lot of people do? They add all these up and they do something weird with the exponents. I don't know. But, so we can't factor out a monomial. Also, I just wanted you to notice is this isn't a quadratic, is it? It's a little more complicated. But we can use something we've learned before. And so what we're going to do is we're going to do what Silas recommended. We're going to factor by grouping. Now, here's the thing. How do you know when to factor by grouping? When nothing combines and you have how many? 4, yeah. When there's nothing that combine and you've got 4 terms, and you got 4 terms, that's your clue that you're going to have to factor by grouping. And you're going to do exactly what Silas said. Silas said, group the first 2. Make sure there's a plus sign, right? In between. Factor out a monomial. What's the monomial here that we can factor out?
X squared.
X squared. Leaving behind.
X plus 2.
Nice. Plus sign. What can we factor out here?
8.
Leaving behind.
X plus 2.
Okay. Now we're back at this kind of, aren't we? Yeah. What's our common binomial?
X plus 2.
X plus 2. Factor that out. What's left behind?
X squared plus 8.
X squared plus 8. Now be on your toes a little bit, because oftentimes when you do this will end up being something. Don't write this down, but if this was like that, see how that's a quadratic? Guess what? You would have some more factoring to do. What would this break down into? X plus 2 and x minus 2. It's a difference of 2 squares, isn't it? I don't know if we do that to you in this section or not. We'll find out. We got some more examples to do. But
Where did you get the minus 4 from?
I just made it up, yeah. But we were actually at what? Plus 8. I can tell you guys that there's no pattern. For one, that's not a perfect square, right? Also, it's a sum. So there's no pattern to break this down. You're done. You are done. And honestly, with factoring, it's as much knowing that you're done as it is knowing how to do the problem. Does that kind of make sense? Okay, well, I think I would like for you guys to try this one out. And I'll come around and check it. Yeah.
If we get like a square root or something, or like x squared,
Uh-huh.
would you always check to see if it has a perfect square?
Yeah, I would. Yep. But even if that was a 4, if it's plus 4, it's not going to break down. It's got to be a difference of 2 squares. Subtraction.
So that's be a negative.
It does, yeah. Kind of tricky, yep. All right, try this one out. R squared plus 4R plus RS plus 4S. Try that out. Raise your hand when you think you've got it. I'll put another one on the board so that you can try it afterwards. Yeah, ladies and gentlemen, if you're good on this one, then go ahead and look at the next one and see if you can figure that out. Is it? When's lunchtime?
11:28.
28.
We have like 10 minutes.
Oh, you got the next one? I'm not gonna check that one just yet, if that's okay. By you. All right. Darwin, did you get something?
No, I'm not even drawing right now.
Oh, shucks. Okay. Well, ladies and gentlemen, so on this one, you got 4 terms, don't you? 4 terms. Do any of them combine?
No.
No, they don't. So what are you gonna do? Group it. R comes out, leaving behind R plus 4. You good? What comes out here?
S.
S comes out. Both have an S, leaving behind R plus 4. And then factor out the common binomial, right? R plus 4, R plus S. And there we have it. We are done. So this next one, any common terms, any like terms? No. There's 4 of them, so what could you try? Factor them by grouping, but I can already see something here. I would probably change that to a plus minus, right? And then I'd group this, but as soon as I group this, would I be able to factor anything out?
No.
So am I just like done here? What's up,
Gotta
Tice?
put it in standard form.
Oh, if we put it in standard form, and what is standard form?
It's greatest degree to least degree.
Exactly, greatest degree term to least degree term. What's the biggest degree up here?
X3.
X3 is the biggest, so it's in the right spot, isn't it? But what should come next?
2x to it.
Yeah. And then what?
Minus 5.
Minus 5x. And then what?
Minus 10.
Now let's try this out. If we factor by grouping here, is it going to be all right? I think so. What can we factor out of this? What can we factor out back here? -5. Very good. And be careful with your signs. You're dividing by a -5, right? And if you divide negatives by a negative, they become... And are we about done? Factor out the common binomial. So we got an x plus 2 and an x squared minus 5 left over. Oh, wait a second. Is this a difference of 2 squares?
No.
No.
5 is not a perfect square, is it? We're done. You just want to check that. How are you guys feeling so far? Pretty good? I think, gosh, I guess I got a few more here. I've got 4 more examples. So it seems like a lot, doesn't it? I've got 4 more examples.
On both sides?
Yeah.
If it's a negative,
And what about the other
so we
side?
just like vary it down and change it to like x minus whatever it is. Or would we do x plus?
Let me see what you mean.
Like, if it was like, set like 4, we change it like
This mine's just way
x
better.
plus 2 or x
It's alright,
plus 2.
Yes. You put both x plus 2, x minus 2.
And
And x. Yeah, you have 3 factors. Exactly. Exactly. Okay, did I say we had 3 more or 4 more? Oh my goodness.
Does
Let's
it
get
matter
going.
what order you put the algebra in?
It doesn't. Because, yeah, it doesn't. Wait, you mean like if you wrote -5 plus x squared? Technically, that's the same thing. I'm good with it. It just seems a little different, but yeah, I'd have to claim that as good. Okay, let's look at something. Again, I just want to remind you guys, knowing when not to do something is pretty important. So take a look at x squared minus 4x minus 3. Is this a special pattern? Is this a perfect square trinomial? It's not. So what are we stuck doing? AC. What's our AC?
-3.
-3. Very good. And then we play what game? What number multiplies by its x, or multiplies to get AC, but adds together and make the middle term, right?
It doesn't make sense.
Oh, okay. So our only options are 1 and 3, and then one has to be positive, one has to be negative, right?
It doesn't work.
And is that going to be possible? Does that add up to -4? Does that add up to -4? When that happens, you're just going to say, not factorable. Or you could kind of think of it as this is the one factor, if that kind of makes sense. But yeah, not factorable is what's the most common thing to say there. And let's go ahead and do this one. 3x to the third minus 21x squared minus 54x. And if you don't mind, let's I'll do this one quietly, and you can work it out yourself, and we'll see if we match. Sound like a game?
Yes.
So you got about 50 seconds. Now time to go to lunch. So please keep working here, and when you're done, see if you got the same answer as me. See if we agree, and we'll go over it after lunch.